I gave the same challenge, the same task, the same environment, same rules to different LLMs across 3 years. And I did not expect most of the results. Before I explain the details about the AI, I'm going to go through about the game and the simulation environment. This is the Frozen Lake, a very famous task for reinforcement learning benchmark. But we are not doing reinforcement learning, we are doing LLMs. The agents or the small characters has to stay away from the water, only walk on the frozen or the safe tiles in order to reach the goal position. By the way, language models are not very great at spatial intelligence. Just like the name stands for, they are good at understanding and generating language, that they don't have a perception of the spatial or the reality. In order to conduct these experiments, I have selected a few models per year, 2023, 2024, and 2025. But before I show you any results, let's see how I prompt the LLMs, because they obviously need a specific prompt. In a system prompts, we just define the game environment, we define the role, and we have also imposed an output format. This is what we call structure output. It can be done in JSON, CSV, or any you like. Second prompt, or should I say the user prompt, this is where we give the directional data. This is where we tell what is in what directions. We give those directional information, and based on the prompt, it should be able to give an action. The action can either be up, down, left, and right. And then we just have to pass this information to different LLMs. So this is how the rules work. If you fall in the water, it is a failure. If you fail to reach the goal before 50 steps, it's a failure as well. But if you reach it before the 50 steps, then that's a success. That is how we are going to evaluate the models. I'll be using OpenRouter to conduct this experiment because it is a very user-friendly platform where you can trust several LLMs. Well, sometimes it does have limits, so that's why I have used DeepSeek and Dashscope as well as the API providers. I have conducted 20 episodes per model, and here's the result. In the first year, 2023, I have tried 3 models: Mistral, Mistrax, and Llama 2. Unfortunately, this is a failure for Llama 2, 0 out of 20. And for Mistral, also 0 out of 20, unfortunately. But this is where it gets very interesting. Mistrax, while being a model as big as Mistral, it still managed to get a perfect score. Now, in the second year, 2024, I have tested Llama 3, Llama 3.1, and Llama 3.2. For some reason, Llama 3.2, I had to pick up the 3 billion version parameters. That is because it was the only available one on OpenRouter. But there is also some vision language in Llama 3.2. Apparently, it does support vision. But because we are restricting ourselves to LLMs and not vision language models, I decided to ignore the vision language model and stick to LLMs only, which is why I had to stick with the 3 billion parameters, which is quite small compared to Llama 3 and Llama 3.1, which has 70 billion parameters. Well, both Llama 3 and Llama 3.1 has done a perfect score, except for Llama 3.2, only 1. Still in 2024, GPT-4o Mini and GPT-4 both scored a perfect score. Also, Quent 2.5 has also entered in the experiment, also got a perfect score. Now, in the third year, 2025, this is where they all smash it. GPT-5 Nano, GPT-5.2, Quent 3 Max, DeepSeek 3.2, and DeepSeek 3.2 thinking model. For those who are not familiar with DeepSeek, it also enables thinking tokens, which means it knows how to ask the question, what question to ask, and how to answer the question before giving us a response to the query. So you might say, yeah, what's the point of this video? Most of the models smash it. Yeah, they did. Most of the models smash it. But there is an important point to make. The current prompt I have showed was the directional data. You tell what is on the what direction. This is not how I have experimented them first. The initial prompt was relying on the 2-dimensional map, like the one you're seeing right now, and then you just pass the user coordinates. At the point you might say, yeah, that's kind of obvious. As a human being, I completely understand the coordinates of the agents and how does it relate to a map. I know that, given those coordinates, I know that the player is placed at the top left corner. Even the annotation, I understand what is the path to circulate to reach the goal. But remember, Large language models, by their own names, they are only restricting to language. No vision, no perception, no spatial intelligence, no language. And this was the main handicap of the experiment. It seemed very obvious, but for an LLM, that doesn't make sense. I even tried when we added the direction into the prompt where the up, right, and left. Honestly, after a few tests, that didn't really change anything. So now the question you may ask is, how bad is this prompt? So I have said that this prompt is bad, which is, but how bad is it regarding the result? Well, in the first year, 2023, all three models failed. Yes, not one single model has managed to complete the game successfully in 20 trials each. In the next year, 2024, that was not much better because the only models that were able to score was Llama 3 and Llama 3.2. Only 1 out of 20. Even GPT-4 or Mini and GPT-4 were not able to solve the task by their own, not even Qwen 2.3. But in the third year, this is where it gets very interesting. In 2025, DeepSeek 3.2 has failed and Qwen 3 Max has failed. However, GPT-5 Nano has managed half of it. It has 11 successes among 20. And GPT-4.2 has reached a perfect score, 20. It's one of the only ones. The only one that is open weight as well to perform a perfect score with this bad prompts is DeepSeek 3.2 Thinking. Well, for GPT 5.2 and DeepSeek Thinking, I had to use 10 trials instead of 20 because the latency was not at the best, especially for DeepSeek Thinking because it takes so much time to think. Well, LLMs cannot think, but I hope you get the idea. Generate thinking token before answering, and surprisingly, it got a perfect score. It was very slow. I haven't analyzed the reasoning process, but somehow it has managed to successfully complete all the trials. So yes, LLMs do not have the spatial intelligence, but this also shows that with some reasoning into the right direction, then we can have. So you might say, what is the point of an LLM thinking? Doesn't think of its own. Well, not really. If you see my previous video where I have explained about generative AI, an LLM is a model that predicts the next token every time, and the output tokens will become the next input tokens in the future. So this is the advantage of thinking model. It generates an output that will be used to shape better the next output. And somehow it has solved a challenge that many LLMs fail because of the lack of spatial intelligence. And an important point to make, LLMs didn't learn anything. They didn't record any past trials, past failures, or past successes. They were just inferring them without the past context. Maybe with the past context, they would have been better. But again, this method of implementing the mistakes of the past experiences has not been implemented in these experiments. So that was it for this video. I hope you have benefited from it. If you are interested about training your own model to text classify according to the sentiment, I recommend this video above, and I'll see you on the other side.